Oh, sad day. That's okay. I get it. Okay. All right, guys and girls. Any questions on the first three?
No.
Okay. So, hey guys, we're moving on. So, any questions on the first three?
Hey, that's what I got.
Hooray. Okay. Now, for 4, I want an exact area of 4.
Exactly.
I did see some of you guys try to approximate it. Do we have a name for that shape?
No.
So if we don't have a name for that shape, we probably don't have a formula for that exact shape, right?
Yeah.
Well, that's the kind of stuff we're going to do this unit. Is find how to find area of irregular shapes. Does that make sense? Okay. So, any questions? You guys see why this one? We'd only at this point be able to approximate it. Okay, good. A couple reminders before we jump into our first lesson here is that with, don't forget the announcement they just said, the college day is canceled because of the online learning day. So you are coming to school on the 20th, okay? And then don't forget tomorrow at midnight is when the AP Central is due to be submitted for the first time, and then your main homework, besides some book work that will be about today's lesson, it won't be a very long assignment though, is over the long weekend would be to do corrections on the AP Central assignment, okay? On your own paper, got it? Hey, I want everybody to watch me so I don't get any of that. I didn't know. I want your paper, your corrections on paper. I will be stamping your corrections. You have to do corrections on paper. That's what I am stamping. Okay, so no one's going to come back and be like, oh, I didn't know you wanted to see the corrections. I want to see the corrections. Okay, thank you. Okay. All right. And then, I don't know if some of you saw it, but on Canvas, I put a couple pictures of some ultra lavas that are up to date as of today. They don't have anything integrals on them. So if you want to see if your ultra lava is up to date, it'd be a good time to go on Canvas and look at the pictures that I posted there and make sure you have everything. Got it? Anything else? I don't think so. Okay. All right. Guys in the back, you're up here? All right. Integrals. Okay, today we're going to start integrals. That's our lesson today. Okay, an integral. Okay, an integral is the inverse of a derivative. So basically, what we're going to start doing is instead of giving f and finding f prime, we're going backwards. We're given f prime, we're going to find f, okay? The other way it's defined, okay, is the area between a function and the x-axis. So I want you to imagine it like this, okay? If I was thinking of it in the physical world, right? We normally think of velocity units like miles per hour, right? So if I want to go from velocity back to position, okay? If I have a time velocity graph, this maybe would be hours, the units, and this is velocity, so this would maybe be miles per hour, right? If I'm finding the area of something, base times height, right? Miles per hour times hours, I'm left with miles. Does that make sense? So what's happening when I find the area between a function and the x-axis is it's taking me from velocity back to position. Taking me from F prime back to F. Any questions so far? Yes.
What is its negative?
What?
What is its negative?
Velocity is a direction, so that would help me figure out where it is, how far the position is from its starting point.
So, is position always positive?
No. Okay. So a negative position would indicate like a distance from the starting point, but like in a,
Too much something you go back.
yeah, exactly. Okay. Anyone else? Okay. The notation for integral looks like this. Okay, this is telling me to find the area between f of x and the x-axis. Okay, before you write it, look up here. I want everybody to look up here before you write it. Okay, what this notation, this is a bullet point, not a negative. Okay, does that make sense? Okay, I want everybody to look up here before you write it. What this is telling me is to find the area between the function and the x-axis from A to B. Does that make sense? Yes.
What if there's no A point, no B point?
So that's called an indefinite integral, and we need to figure out how to do definite integrals before we do infinite integrals, okay? Or indefinite integrals.
I was wondering if that's a thing.
Oh, it's a thing. It's a thing we'll spend a lot of time on. It's
Yay.
not today, okay? Feels like it's been forever since I've done an actual lesson. Weird. Okay, I know. What? Okay. Now, the whole point of that bell quiz, in quotes, that I did earlier, is because what we're going to understand when we do integrals, before we can find them exactly, we have to estimate them, okay? We did that with derivatives too, right? Remember when we first started derivatives, we started with tables, and we tried to get the secant lines as close as possible to get the best estimate as possible. We're going to do a similar idea today, estimating integrals as best as possible. And that idea is called a Riemann sum. Riemann is just some old dude's last name, okay, that came up with the idea, all right, on estimating integrals. But that's what these are called, Riemann sums, okay? So far, okay? Any questions? Yes or no? Questions? No? Okay, cool. So make sure you're going to want calculators today just to do some of the math quicker. Okay. So let's say I've got some function. It's not a circle. If it was a circle, okay, it would make it easier because I could take the area of a circle formula, right? But a parabola, you guys listening? A parabola is not a circle, right? I can't use pi r squared to find the area from a parabola. So let's say I had this function. We'll go, so this would be the equation y equals x minus 3 squared plus 1. Okay? So this represents the derivative of something, okay? And I want to know how far this object traveled from 0 to 4 seconds, whatever, okay? So to find that, I'd have to find the area, okay? So first let's write the notation of that, right? The notation of that would be the integral from 0 to 4, right, of x minus 3 squared plus 1 dx. So that's saying I want to find the area between that parabola and the x-axis from 0 to 4.
What's the dx?
Huh?
What is the dx? That just means
The x-axis.
Say
Kind of. No, we'll talk about dx again.
Is the 0 to 4 the x-axis?
Good. A and B is a domain. Okay? Let's make sure we note that here. If that, so the A and B is the domain. Good. Okay. So, what I'm finding,
Bless you.
is this area. I don't know if well, you can write those if you want. But I'm about to erase those marks in a second because I can't use different colors. Does anybody watch the videos? Is there any color besides black that will show up?
Blue.
Blue shows up?
Yes.
Green is the one that doesn't, right?
Yeah.
Okay.
Green is very. Oh, so what's that secret word on that one video you did?
No, I don't remember. I don't remember what I had for breakfast yesterday. I don't remember. Yeah. Okay. Okay, there's too many things in my head. The ones that aren't important to me, I let go. Okay. But do you see how I'm finding the area of this shape, right? I'm finding the area of that shape. Does that make sense? Okay? Because if my velocity, right, the y-axis is like a miles per hour, and the x-axis is like in hours, if I find the area, right, think about how the units are going to cancel, I'm going to be left with miles. That's what I'm doing right now. I'm doing the inverse of a derivative. Inverse, opposite, right? Got it? Okay. What's the name of that shape? Is that a pentagon? Is it a hexagon?
It's a squiggle.
It's Idaho. Okay, it does kind of look like Idaho. Okay. This is some irregular shape. It does not have a name. It doesn't have a formula. It's too random of a shape. I can't assign anything I draw with my pen a shape, right? Okay. So for now, there's no way for us to find what this area is exactly. Is that fair? So what we're going to do is use easier shapes I can find the area of to estimate the area of this shape. What's the easiest shape to find the area of?
A square.
A square or a rectangle, right? So that's what we're going to use, okay? So I'm going to decide first how accurate I want my estimate. For this first one we're going to do, I want 4 sub-intervals, okay? When I say 4 sub-intervals, that means 4 rectangles. So how wide is each rectangle going to be? 1. That is known as my dx value. The length, dx, is the length of each sub-interval.
Can you take the limit of that as that approaches 0?
That's how we do it exactly. You guys heard what Jake said. He said, can we take the limit as dx approaches 0? The idea to find exact integrals is that's what we're going to end up doing is the best estimate is going to be the limit as dx approaches 0, or n, which was defined as the number of rectangles, right, approaches infinity. But for today, let's just worry on getting estimates, and we'll do the exact ones with limits later. Okay? Good. Anyone else? Okay, so I know this first subinterval is going to go from 0 to 1. Is that good?
Yeah.
Now, here's the next thing I need to figure out. How tall is it going to be, right? Because the area of a rectangle, I need the base, I have that. That's my dx value, right? But now I need my height. Okay? Yeah.
You just plug in the y-intercept, so x, or you plug in 0 for x.
So that's a good guess, and that is what we're going to do on this one, because what I'm going to show you first is called a left Riemann sum. Okay? So what I'm going to show you first is a left Riemann sum. So here's the idea. Okay? If I'm going to take this rectangle, I have two options to decide how tall it is. I have the left end point of the subinterval, right? Or I have the right end point of the subinterval. So for a left Riemann sum, I'm going to use the left end point of the subinterval to decide how tall my rectangle is. Oh yeah.
Just like alternate.
So this right here, this rectangle is going to estimate that portion of the area. Does that make sense? Mm-hmm. So if I want to estimate that entire thing, okay, I'm going to draw my left Riemann sum for each one. So now this subinterval, right? I have two options, but I'm using the left one. Huh? Well, right now I'm doing a left Riemann sum. We're going to do a right Riemann sum after, okay? So then I go from here. So of my subinterval, I go to my left end point, and that's the height of each rectangle. Are all of those rectangles an overestimate with this left Riemann sum? Mm-hmm. No, that last one would be an underestimate, right? Does that make sense?
Yeah.
Kind of balances it out a little, right? I want us to find the estimate of this integral using this left Riemann sum. So, what would the base length be for this first blue rectangle?
1.
And what's its height?
F of 1.
F of 1? F of 1?
No,
F of 0. So find it. Then the next rectangle, 1 times what? 1 times, so this was dx times f of 0. This is dx times f of 1. So dx times f of 2 plus dx times f of 3, right? So this one is 1 times what? 5 plus 1 times what?
2.
So I told you in this instance that I wanted 4 rectangles. So my interval length is 4 things long, 0 to 4. So if I want 4 rectangles, I divided it by 4.
I didn't use the right Riemann sum in the last one.
I didn't because the left, look, if I used the right one, I would have used the right endpoint and the rectangle would have been taller. Okay?
Okay, wait, so you find the base is 1 and you find the f of 0 and
Mm-hmm.
oh, then you just add. Okay.
And then f of 3 is what?
1.
So the approximation of this integral would be 18.
Can we do that funny shape as we had question before?
No, we don't have time to do one with that many things. Okay, here's what I want you to do. I want you on your notes, I want you to sketch this graph again. Don't do it on this same one. And I want you to attempt drawing the rectangles if I was doing a right Riemann sum. Okay? So I want you to sketch this exact same quadratic again, but I want you to attempt drawing your rectangles if I asked you to do a right Riemann sum.
With the same equation?
Yep. Now careful, you should still be doing your rectangle at 0 first. The right doesn't mean I start from the right. I still read my graph like a book, left to right. It just means between 0 and 1, f of 1 is how tall my rectangle is. Okay?
Wow. Those rectangles are tiny. Is there a way to rotate that when you're writing it out? Or
How to notate, like the notation I put on the left there?
yeah, first one. There you're gonna write. So like there's
You just have to be told which one it wants. If you're understanding the boxes, how you got it, I'd like you to try and find that right Riemann sum now. Oh, right. I started writing. It's funny. Let's try that again. So this one would be dx times f of 1 plus dx times f of 2 plus dx times f of 3 plus dx times f of 4, right? So 1 times 5 plus 1 times 2 plus 1 times 1 plus 1 times 2 again?
Yeah.
Okay, so this approximation would give us 10.
Mm-hmm.
Cool. What questions do you have so far? Anything so far? We've got one more type of Riemann sum to talk about, and then we're going to try another example. like up with a new equation. So do you notice that the location of my rectangles is in the same spot? It's not like I started on the right for the right. It's that the right endpoint of my subinterval determined my height of my rectangle. You guys with me? This one is going to be an underestimate for sure, right? Well, what should we do first? Let's do, well, those aren't triangles. Those aren't triangles. Let's do this. We're going to pause on this for a second, and I'm going to give you guys something to think about with your neighbors. Here's our 4 basic graph shapes, right? Those are our possibles of concavity and increasing and decreasing. I'm going to give you 5 minutes with your neighbors. I want to know, based on those 4 basic graph shapes, when will a right Riemann sum be an over versus an underestimate of area? And when will a left Riemann sum be an over versus an underestimate of area? Does that make sense? So decide of those 4, when will my right and left sums be over versus underestimates? You guys understand what I want?
Yeah.
Okay, 5 minutes with your neighbors.
This way, the left is over. So if it's like this, the left is over.
This one is the east one, right? This one's right. So all of the last one would be
And then this one is the other way around, right?
I think so.
no, that's just
If it helps, use the graphs we just did, and or feel free to draw, make a sketch on those.
Bottom right, left be over.
That's what I'm thinking.
Because if you're drawing the box from the bottom, you're going up. You want it to go as high as it could to
Well,
cover more. Or are you gonna find,
would it go
you find
under,
this
though?
area? Because you're finding this area, right? Because the axis is right. The x-axis is right here.
Oh yeah, you're right. Because it's according to the x-axis.
So then you want it to be as far up to the left as possible to cover.
Well,
This
the
much.
x-axis isn't necessarily right there, is it? These are just 4 different graph types. Because it could be below it.
Yes. Then how would you know which way it was?
What?
Another minute?
Wait, I got a question.
Yeah.
So like on this one and stuff, would like the x-axis be right here? Or is it like the x-axis is below on all of these?
Either way, doesn't matter.
Doesn't matter.
Well, oh yeah, think about the x-axis under for all.
Under.
Yeah.
Okay. Yeah, so if there's like underneath it for these. And then the left, I think left is going to be under.
You just stop at the end point, right? So left would look like this.
Right would be over, I think. And then it's got to be the other way around. For the other ones. Yeah. Sure.
The more that I keep telling myself I'm right, the more I'm convincing myself I'm wrong. Like, I'm like, yeah, this makes sense. Wait. And I think, does it really make sense? I'm second guessing
Yeah.
myself like crazy.
I do that too much, and it's not good. Because there's so many times where I have the right answer at first, and then I second guess myself. I think.
Go with your gut feeling.
Mm-hmm.
Yeah.
Okay? Over or under?
Under.
Under?
Yeah.
What about here?
Over. Over.
Over.
That one's on.
Over.
That one's over.
Over.
So definitely over.
Under.
Over.
Over. Under. Under.
Is there a way to generalize that pattern together? Yeah.
If your graph is increasing with the rate Riemann sum, be overestimated.
Say that again louder.
If the graph is increasing, the right Riemann sum would be an overestimate. If the graph is decreasing, the left Riemann sum would be an overestimate.
Concavity doesn't make a difference. Good, Carson. The concavity, did you see that? Doesn't make a difference, right? If the graph is increasing, right? When the graph is increasing, then my left is an underestimate and my right is an overestimate. Okay? And if my graph is decreasing, then it switches. Does that make sense? We doing okay? That needs to go on your ultra lavas. But I want to simplify it a little. You can write it however you want. But my left Riemann sum is always an underestimate for increasing graphs. It does not matter the concavity. Okay?
Want to read you? Oh, I do have my ultra lava today. I want to read you my ultra lava so bad. Plus, I don't have like half the things on here because I forgot it a couple times.
Anyone need more time to get down their ultra lavas? All right, I got one more type of Riemann sum to go through. Riemann always means rectangle, so keep, think, you want to imagine that, okay? So, there's got to be a better way, okay? Oh, I asked if anyone needed more time. I'm sorry. Can you get it from one of these guys? Sorry. Or you can watch the video.
That's what I was planning on doing.
Okay. The last type of Riemann sum is an attempt to balance out the estimation of these ones. Okay? It's called a midpoint Riemann sum.
Oh. Why don't you just do average?
Okay? So what we're gonna do, we're gonna use the same graph because I want to be able to compare all 4 of the graphs together. Okay? I mean 3. So I'm still estimating the same thing, but I'm attempting to get a better estimate. All right? So instead of using, okay, the left endpoint of the subinterval or the right endpoint of the subinterval, I'm going to use the midpoint of the subinterval. What do you think that means?
Average of 2 points.
The average of the 2 points? What do you think I'm averaging?
Like
The
that.
left and the right are your X.
X's or f of x's?
X's.
X's. It's the middle. So when I'm doing this first point here, instead of plugging in f of 0 or f of 1, I'm plugging in f of 0.5 or 1/2. But notice my dx is still 1, right? So my rectangle's still covering from 0 to 1, right? But in an attempt to balance out the over and under estimation, okay? In an attempt to balance out the over and under estimation, I'm going to use the midpoint.
You're saying this is the most accurate?
No,
Okay.
so far. We're actually going to talk about next time that there's a better shape than a rectangle to get a better idea.
No, it's really tiny.
Trapezoid.
Oh.
Why?
Oh.
But don't worry about that today. All we're doing today is rectangles. All we're doing today is rectangles, okay?
Is it because it's just a rectangle with a triangle on top of it?
Well, the idea is that, don't forget, this
Yeah.
is a trapezoid,
Uh-huh.
right? So there's a better shape. But for today, we're just doing rectangles, okay? Don't jump ahead, but if it's about trapezoids, I don't want you to ask. Okay? Okay, go ahead.
It's a little bit better than that.
Well, yeah, the limit is the exact.
Okay.
Yeah, and the trapezoid is still an approximation. Okay?
Okay, well, she said there's a better one.
I didn't say best, I said better. So then what am I plugging in for this second rectangle? 1.5. For it. The dotted line helps me, helps me. Like always want to do a left for some reason. Okay?
It's because you're right-handed. Yeah, there's less extra space on these ones.
Anybody already found the f of 0.5 yet?
Yeah, what I'm writing down is
Yeah, you're good. 7.25, f of 1.5. Hey, don't forget that table thing I showed you to make this go much faster. Set your table to ask for the independent variable, right? Then you can just type in the ones you want real quick. Remember?
I don't.
1.5, it's 3.25.
Okay. Then here, is that right? I think it's right, but I'm not sure. Yeah? Is that right? Yeah? Okay.
No, so add them together. Okay. 11, 12,
How do you move your
13.
table, make it ask you for
Roughly 13.
Click on table settings or table format, and you clicked on ask for the independent.
Okay, so like 18 plus 10 is 28 divided by 2 is 14. So if you like either the other and then average it out, it would be as far off, but it would still be up more than the midpoint.
Notice that all of these have the same number of rectangles, right?
Yes.
Mm-hmm. So what's my estimate here? Anybody already add them up?
13.
Should we use our calculator to find the exact to see which estimate is closer? Math 9. Math 9. I think it's math 9.
Yeah.
Okay. Whew.
I got it right. 13.333.
What's the actual answer? 13 and a third?
Yeah, it's 40 thirds.
So 0 to 4 of this function, the actual answer is 13.3 repeated, right?
Yeah.
So this one, where the majority of the part we're covering is increasing, right? Sorry, the majority of the part we're covering is decreasing, and right Riemann sums are underestimates for decreasing. That's why this estimate is below the actual, right? The majority of this one is decreasing, and left Riemann sums are overestimates when the graph is decreasing, which is why this one was bigger, right? Keep this in mind. The majority of this one is decreasing, right?
Mm-hmm.
So maybe midpoints when it's decreasing, maybe under, I don't know. Keep that in mind. We'll talk about that more later. It's harder to tell on the midpoint one, right? But look how much already closer it is, right? Okay? How are we doing, okay? So you're using the midpoint of the subinterval to find the height. So it's the I just put here to clarify the midpoint of the dx part, right? So that's why we put in 0.5 when my interval went from 0 to 1, okay?
Is it,
Yes.
is it plausible if they would take the average between the left and the right Riemann sum?
The average between the left and the right,
It comes out 14.
Because it's kind of close.
It comes
yeah,
with
it's kind of close.
It's
You
less.
can, but it's just another step. So what the problem, I mean, it's not a problem. I could to get a better estimate, I could average these, but then I'm still finding 2 Riemann sums. This one's gonna be close to that kind of still, but then I'm still only finding 1 Riemann sum. It's just a lot less work. Okay, Ethan?
Will the DX ever not be one?
Ah, yes, the dx is something that's defined for you. Sometimes we even have a dx value that's not the same for each rectangle. Okay? So we're going to do another one similar to this first, and then I'm going to show you an example of when the dx maybe isn't the same as each rectangle. It depends on what info you're given, okay? Here's what I want you to do. I want you to, I'm going to give you guys probably 10 minutes to work on this with your neighbors, okay? I want 3 estimates of this. No, let's do 1 to 3 of ln of x. And I want, how about 4 subintervals? Again. Okay? So here's what I want. I want 4 rectangles, right? Does that make sense? Okay, I'm going to give you guys 10 minutes with your neighbors. What I want is 3 sketches of this because I want 1 to show me you know how to draw your left Riemann sum rectangles, 1 for your right, and 1 for your midpoint. Then I want an estimate of each of those integrals using each of those Riemann sums, and then we'll find the exact one to check. Does that make sense? Hey, what's our dx value in this case? 0.5. Good, Carson.
Where's the graph?
Right here.
Oh, it's 0.5.
Exactly. So it might be a good idea too, because I'm going to have you do it eventually, to start thinking about, is there a general equation to come up with my dx value based on the information in the subinterval setting? We'll talk about that too in about 10 minutes. Okay? Do you guys understand what I want?
What does the graph look like?
Just like this. This is for a window of just the max being 1. So
And midpoint. I want left, right, and midpoint. So 3 graphs, 3 different graphs with 3 different rectangles being drawn.
1, 2.
goes a little bit over for y. You don't need.
What's 0.75? You say? So careful, because I'm not going from 0 to 3. I'm going from 1 to 3. So I'm doing 2 divided by 4. So each one is 0.5. Does that make sense?
I'm doing a midpoint.
Wait. Going to, from 1 to 3. Then we do like, and the intervals are half.
Yes.
Normally I'd have you guys come up and draw the rectangles and stuff, but because I'm recording this for 2 classes for tomorrow, I'm going to be a little particular about how the rectangles are drawn. So I'm going to do it.
What does it mean if like ln of 0 is an error?
ln of 0 is an error. That's because 0 is the vertical asymptote. But you shouldn't be plugging ln of 0 in for anything.
Oh, 1.
Does that make sense?
Yeah.
How do you use it?
I just needed the graph.
Yo.
All I've done so far is my pictures. So you can check your pictures.
Wait, what is the point of graphing the left side and right side midpoints? It's obviously a better choice always.
It is always the better choice. It's so that we have an understanding of the foundations of what we're learning. It's why we learn about addition before we learn about multiplication.
It's why we learn how to do all of the things by hand, and then they give us the shortcuts on the calculator.
Yeah.
So now you know how to do it, just in case. And I'm like, I forgot my calculator, but I did find it, so.
Well, that's good. Baby steps, right? About 5 more minutes. Let's pick out.
No, not from the book.
Sorry.
Anything but the book.
You like AP Central better than the books?
Oh yeah, so much.
People do not say that.
I just don't like the book at all. I never do the books.
Just think about it.
You're content. I'm not content.
Well, I'm getting 65 to 70% on the AP. So that's going to be a good grade on my AP exam. So I'm going to waste my words.
But
78. Yes, I'm going to have to do more.
the third error in says if you get a divide by 0 error. She's just astounded that you did that. Thought, really? Really? The third paper in at the top
That's
for
funny.
calculator errors and what they would mean. It's funny.
Okay, can I have someone come up and do left? I need someone for left, right, and midpoint.
Just for what we got?
Well, yeah, what you got is fine. I don't care. I just need someone to come on up.
I'll do left.
The left?
Or you got left, I'll do left. Can we show them that? Or just...
You can't write in green. You can't write in green.
Oh yeah, don't write in green, black or blue. But the right one is the midpoint one.
No, I was just telling him how I did it.
Oh, okay.
It's so itty bitty.
You guys agree with these numbers? Is this what you guys got? Yay or nay? Hello?
Yes.
You guys agree?
Yeah. Which one?
All of them.
All of them?
Oh, the first one, yes. Right
What do you
one,
think?
yes. I think the midpoint is wrong.
So
I don't know.
raise your hand if you agree with the left one.
Yeah.
Only 3?
Okay.
Did I not give you enough time, or are you getting different answers?
I think it might be different answers.
Come on, peeps. Talk to me.
I mean, I wrote the left one, so I think it's right.
We are wasting
I
time.
can't help. I'm sorry.
I say it's good.
I think I like
Would
But not even half the class raised their hand.
So I think it's wrong. I was trying to.
Someone raise their hand and talk to me. Yeah.
I think it's good.
Okay, should we go?
Yeah.
I think they're right.
I say yes, and I'm only going to raise my hands.
You got 1?
That's what I got.
I got like 1 point.
Uh-oh.
I might have an idea.
Half of us have 1 and half of us have the .661. Okay, let's go through it. Go
I've
ahead.
done it wrong.
I think the reason that we're getting different answers is because we're starting at 1. Some people might have put in like 0.5 for their integrals, but they should have like 1.5 for the x because we're starting at 1. And so if you do like, and so you put in any x values before 1, you're going to get a different answer.
That's true. I didn't get either of those things.
What did you get?
0.7.
Oh, what?
3. Wait a minute. I don't think that one's right. Hold on. So 1, ln of 1 is 0. That one doesn't matter. Yeah? ln of 1.5 times 0.5 plus ln of 2, right? Times 0.5 plus ln of 2.5 times 0.5. 1.007.
Oh, I'm getting that now.
Yeah, that's what it is.
That's what I meant to.
Good?
Yeah.
Oh,
Must have did math.
So I did ln of 1 times 0.5 plus 0.5 ln of 1.5 plus 0.5 ln of 2 plus 0.5 ln of 2.5.
midpoint should be in between the two,
That's what I did.
and it's not. So there's a little something wrong with all of this.
Yeah,
Next one too.
Yeah.
That's what I did on the midpoint one, and that's what I got.
Wait. That's funny.
Well, the midpoint should be in between the left and the right.
Yeah.
Oh yeah, it should.
Yeah, so the right one.
One of
The
them-
right one, I got the same thing for the right one.
Yeah, the
Right
right one
one's
should be
correct.
right.
The right one is basically this again, but instead of this,
Start at 1.5.
you add 0.5 ln of 3.
Why is it 0.5?
Yeah.
Because that's the dx value.
Yes.
So if my interval is 3 minus 1, and I want 4 subintervals,
Oh.
okay? So just times your answers by 0.5, okay? All right.
It wouldn't be the same if you just multiplied ln of 1 plus ln of 1.5. If you just added all those up and then multiplied them all by 0.5.
Yeah, it would.
That would give you the same answer.
Yeah, it was the same. That's what I did.
It made it a heck of a lot easier.
I was like,
But you add all of the LNs together.
So then this one would be
Yeah, they're saying to do it.
0.5 ln of 1.25. 0.5 ln of 1.75, 0.5 ln of
2.25.
2.25,
And then 2.7.
Oh yeah, I didn't multiply by 2.5 at the end.
and 0.5 ln of 2.75.
So it's half of whatever this is.
Yeah, and that's average between those pretty much.
I got 1.303.
Yeah.
Yes, because it's half of that.
Got that too as well.
And then math 9 to check is 1 point. So the actual answer is 1.296. I guess that's still technically an approximation because I rounded it.
Okay, so how do you do that thing with that check again?
Better?
Press after math
Okay.
line. Mine's
Uh,
might look different.
Couple things.
What do you type?
No, we can do one
Stuff
more.
like that, and then I type in 1,
Okay.
3.
I'm gonna move on. It's gonna be a little different. We're gonna do it with a table this time instead of with a graph. Okay? And not all of our dx values are gonna be the same. But if they are the same, actually, we need to come up with, if I have an integral a to b f of x dx, and I want n subintervals.
E minus A over N.
Good job. B minus a over n, good Ethan,
You're
is
easy.
my dx.
It's already up there.
It is?
Yeah, well, you put
Oh,
it.
yeah.
Yeah. It's, yeah.
Okay.
Okay.
Okay. So that's if, now that works if all my subintervals are the same length, if my dx value is the same for all my rectangles. But sometimes I don't have enough information to do that.
So you can like do it with different DXs?
You can, you just have to think about each triangle or each rectangle individually.
Okay.
So let's say I have some table,
Everything.
okay, and I want
Hold your applause for those.
0, 1, 2, oh no, 0, 1, 3, and 8. Now, here's where you want to be careful. The word area implies positive, but when we're dealing with integrals, it's called signed area. Not trig sign. You guys always think of trig sign. Signed area is what we're dealing with right now. What that means is that I still am dealing with negatives, meaning direction. So sometimes my rectangle might be below the x-axis, and if it is, it counts as a negative height. Okay? Now let's estimate. Now, I don't have a function, right? I want to do the same dx value for each rectangle because it makes it easier. I can just multiply by that dx at the end, and it's usually a better estimate, right? But if this is the only information I have, I can't do that, right? So I'm going to have how many rectangles in this case? 3. I can't have more than 3 because if I'm assuming, right, if I'm thinking I can have more than 3, then I'm assuming that the points are connected linearly, but we have no idea if that's true, right?
Yeah.
So what we'll have is 3 subintervals of different dx lengths, right?
Wait, that's
So I want to use a left Riemann sum to estimate the integral from 0 to 8 of y dx. So if I don't have any more data, I can't split those intervals up but more than what they're given to me, right? So do you guys see why each rectangle has to have a different dx length, right?
Mm-hmm.
So what's the dx length of my first rectangle? 1.
So it would be -3.
And if I'm doing a left sum, which endpoint of this subinterval indicates the height?
The 0.
This one.
Yeah.
So how tall is this rectangle?
-3.
Good. So there's my first rectangle. And I'm using the left endpoint to determine the height, right? Yep. You don't have to draw this unless you think it'll help you visualize it.
Wait, that doesn't have to be even rectangles though?
Only if I can. Okay, so on this one, this first subinterval went from here to here, right? It's still always from the x-axis, but which of the ends am I using? I'm using this one. Right?
Yeah.
So then the next one would be from 1 to 3, right? So its dx value of this next one is 2, and how tall is it?
1.
It's 2.
It's 2 wide and 1 tall.
Oh, so the next one's dx is 5.
You got it. The next one's dx is
And then you
5.
5, 5.
So 5.
Cool.
And it's how tall?
5.
So 25, 27, 24 would be my estimate as best I can get of this subinterval.
Fantastic.
Does that make sense?
Mm-hmm.
Yes.
So if I can do dx values, just to summarize stuff, if I can do dx values that are the same and small, then I want to, that's a better estimate. If I have enough information to be able to do a midpoint Riemann sum, that's a better estimate, right? But in the end, we just do the best estimate we can based on what information we have. So this one's estimate's probably not great, but it's the best I can do. Does that make sense?
Mm-hmm.
Awesome. Homework, I've already picked it out. It's going to be, I'm going to text it out too. I'm going to text it out. Yeah.
I probably got time to do this today. I'm in class, but the bell rang, so I got like a picture of it.
That's fine. Do you need a stamp or something, or you want to grade?
I haven't done this at all, so I need a stamp and.
Well, it's half credit, right? 'Cause you were here.
I was going today, I was just getting out, because I think classes.
Okay. Okay, then, so grab your stamp sheet and I'll give you a stamp for it.
Okay, cool. Thank you.
Thank you.
The video's still filming. Do you want to stop it?
Yes, will you, please?